Yes. Okay. So in order for us to prove similarity, and we focus on triangles, since triangles have 3 angles or 3 sides, we need to prove 3 things. So for similarity, a reminder of what our symbol for similarity is. So in order for 2 triangles to be similar, they must have the same shape and they must be proportionate. Okay, so that means their sides are in proportion. So size is proportionate. So if I only have 2 things in a triangle, angles and sides, that means one of them must influence the shape and the other one must influence the size. Which one influences the shape? Angles or the lengths of sides would influence the shape of that triangle. The angles. Why would it be the angles? Well, let's have a look. I have a triangle here. I'll put it back now. I'm going to increase this angle. See how increasing that angle completely changed the shape of my triangle. Whereas if I had the angle and I had the same angle, but I just increased the size, the shape is the same, but the size has increased. So my shape is influenced by angles. So for the same shape, we would have to have corresponding angles that are equal. We are writing this down, please, because we actually want to pass at the end of the year. And for the size to be proportionate, the side lengths are in proportion. So we have 2 proofs to prove similarity. Either we're going to prove that the corresponding angles are equal, or we're going to prove that the sides are in proportion. I want to make a note on this proportionality because a lot of learners don't really understand what we mean by proportionate. So note on proportion. So for proportion, the same factor exists between all sets of corresponding sides. Okay, so just to get our heads around proportionality, if I start off with 3 and it is increased by a factor of 2, what would my new length of line be? 6. A factor means we are multiplying by. So it would be 6. So we are timesing by 2. If I had 18 and it was increased by a factor of 3, what was it? It was 6. 6 times 3 gives me 18, or you can go in the reverse. 18 divided by 3 gives me my 6. Now I went from 2, I went to 8. What was my factor? It was 4. How did I find that? Well, 8 divided by 2 gives me my factor of 4. Now we apply this to triangles. Okay? So I'm going to draw 2 corresponding triangles. So for the time being, this is a corresponding side to this. I am telling you this much. That corresponds to that, and then the 2 straight lines correspond. So if I have a factor of 5, that means that this one to that one increases by times 5. That line increases to that line by times 5. And this 6 will increase to that line by times 5. So each of those sides have the same factor of 5. And since that factor is the same for every single pair of sides, because that's a pair, and that's a pair, those factors are the same, we call it proportionate. There is no differences. All of them have a factor of 5. So if I start by 2 and I increase by a factor of 5, what is the new line? If I start with 6 and I increase by 5, my new line is? And if I had 15, what was the initial one?
3.
15 divided by 5 gives me 3. So that's just a quick reminder on what similarity means. What similarity means and proportionality between sides. Now we're going to write down our very quick 2 proofs, and then we just for the rest will be going to practice example after example after example. Anyone still busy? Can I go move on? Okay, format of proofs. There are 2 of them, and we're going to do both of them. I'm going to do them side by side so that we can see the difference. So I'm just going to draw a line down here. So I always start, no matter what, in naming the 2 triangles that I'm going to work with. Since they give me angles, we're talking about here, given info on angles, I would make a statement about my first corresponding set. So my first one, the reason that allowed me to say that. and my third set that allowed me to say that. But all of them are about angles. I would end off by saying, therefore, triangle is similar to the second triangle, and the main reason was angle, angle, angle. Once that I know that they are similar because of their angles, I can also infer that their sides will be in proportion. So that is the inference that I have made because I've already proven similarity. In my other option, because there's only two, I also start by introducing the angles. But now I'm given information on the side lengths. I will calculate side 1 in my first triangle over side 1 in my second triangle. So triangle 1, triangle 2. Get an answer. Calculate the second side from triangle 1 and the second side from triangle 2 and get an answer. My third side from triangle 1 and my third side from triangle 2 and get an answer. And these answers must be the same. So the star is just telling you that they must be the same answers. Therefore, triangle A whatever is similar to the second triangle. My reason, sides in prop. Now that I've proven that they are similar because the sides are in proportion, I can infer that corresponding angles will be equal. I'm going to do an example of each straight after we finish writing this. So can you see how one, we are proving angles, and therefore we can say that the sides are in proportion. In the other one, we are proving the proportionality, and therefore we can say angles are equal. Those are the only two proofs that you have for similarity. When we do the examples now, we're going to do the most basic examples so that the rest of the week we can build up to the trickier ones. Is anyone still writing? That's fine, I'll wait. Okay, let's look. So here I'm asking you to prove that two triangles are similar. What information do I give you? Sides or angles? Angles. So I'm going to prove that corresponding angles are equal. Now I start my proof. In triangle, I'm going to start with ABC. And triangle, can I say DFE? Because I went ABC, so DFE makes sense. Not necessarily. I don't have to go in alphabetical order. There is something that I have to look for though. I have to make sure that the angles are matching. Okay? So if I have 80 at A, and A was my first letter, what has to be my first letter in my second triangle? It has to be D. My second was 30 and it was B, 30 and E. Matching C was 70, 70 is F. So here it is coincidence that they are alphabetical. Complete coincidence. We had to match those angles. And now we write what we know. We know that angle A is equal to angle D. What's my reason? It's given to me on the page. Angle B is equal to angle E, also given. Angle C is equal to angle F, also given. I have 1, 2, 3 pairs of angles that I've proved. Therefore, triangle ABC is similar to triangle DEF, and that was angle, angle, angle. I know that they are similar. I just proved it, right? Now I know that sides are also in proportion. So I'm going to end off by saying which sides are in proportion. My first 2 letters, my second 2 letters, and my third 2 letters. I mean first and last, so A and C. I'll show it to you in a moment. So what I've done is I've taken AB, BC, and AC as my 3 sides of my triangle. And they are proportionate to AB was DE, BC was EF, and AC was DF. So for that case right now, I actually looked at the triangle and I found corresponding sides. But if you name your triangle correctly, we can actually find it in the name of the triangle. AB and DE, BC and EF, and AC and DF. So we don't actually need to see the triangle to know which sides are in proportion. And since they are in proportion, that means that if I take this side and I divide it by that side, I'm going to get a number. And that number will be exactly the same number as this side divided by that side, or that side divided by that side. Because the answer to these are the factor that we increase or decrease by. So they have to be the same when I get those answers. So I proved by angles, and I therefore know that those sides are in proportion. Let's prove the other one. Using the other one, just as easy. It's 1, 5, 1, 5. And I want to prove similarity. Okay, so if we went alphabetically, we would say PQR and QRS. Okay, but that is not necessarily the order of the triangle names. So I'm just going to start with my first triangle, PQR. So in triangle PQR and triangle, and I'm not going to name it yet. Okay, I'm just going to leave it right now because I'm not sure what the names are. So I have PQ divided by PS. So actually I would give you the names, but right now I'm telling you it's PQ divided by PS. That is 10 divided by 5.
No, why not PQ divided by QS?
Oh yes, QS, sorry, thank you. PQ and PS. And I'm going to simplify. 10 divided by 5 gives me 2. Then I'm going to go QR. And I'm telling you that it's RS. Even though you would be very tempted to say QR in both. But just because it's shared does not mean they are corresponding. So QR is 3, RS is 1, 5, 3 divided by 1, 5 is 2. And then PR divided by QR is 6 divided by 3 equals to 2. Same, same, same. Therefore, triangle PQR is similar to triangle. Now we actually need to know what the names are. So if we have PQR, we're going to have QS. So PQR, so the 10, the 3, and then the 6. So then it would be QSR because it would be the 5, the 1, 5, and the 3. So QSR. Sides in proportion. So in a test, when it came to the side lengths, I would actually give it to you, and then it becomes a little bit easier to see which sides. PQ, QS, QR, SR, and PR, and QR. So if I gave you the names, it would have actually been very easy to see which sides you have to prove. Because if I didn't give it to you, it was a little bit confusing, right? Because you would think that the 3 and the 3 must match. But that is not always the case. So since we know it is similar, which angles correspond now and are equal? P and P here. What about this triangle? So if it's first, second, last, and last. But I can't use only one letters, because in some cases, if I say Q, then I'm actually referring to the whole angle. And if I say R, I'm actually referring to the whole angle. So I'm going to have to use 3 letters. So QPR is equal to, so this one, Q in the second triangle, that one, so SQR PQR, so this dot over there, going to be QSR, that dot over there, And my last one, QRP,
Would you please just a reminder that
SRQ.
the bottom B wing and C wing can leave. The second bell indicates Hayward Centre, upstairs A wing and C wing may leave, and the third bell for the upstairs B wing and all the other areas. Thank you.
So those are the two proofs that we will be using from tomorrow onwards. But obviously it's going to get more difficult. I'm going to throw in vertically opposite angles. I'm going to throw in straight line. I'm going to throw in parallel lines. I'm going to ask you to prove and find the missing sides. So we are going to build up to more difficult things. But today was purely what you would have done in grade 8. And I know Ms. Saunders did it with you. And I even have the worksheets that she gave you last year.